Simplify each expression. Now that we have experience with the rules of exponents as well as negative exponents, we've got a few exponential expressions that mix several of the rules that we've learned so that we can make sure we get practice using them all together. Let's look at them one at a time, keeping in mind that each one uses different rules. First, we'll look at a to the 5th over a to the 15th. Now this is a quotient of two powers, so we know that we can combine them by taking the difference in the exponents. If we do that, we get a to the 5 minus 15th power, which gives us a to the negative 10th. Now we're not allowed to leave it like that because we don't want any negative exponents in a final answer. So to change that negative exponent to a positive, we move it to the denominator and we get 1 over a to the 10th. All right. Let's look at the next one, 24b to the 6th over negative 4b to the 8th. First, we'll look at the coefficients. 24 can be divided by negative 4. That gives us negative 6. And then if we look at the b's, we can subtract the exponents. And 6 minus 8 gives us negative 2. So we get negative 6b to the negative 2nd power. We have to make that negative exponent positive, so we're going to have to move that b to the bottom. However, the negative 6 stays on the top because it doesn't get affected by a negative exponent. Moving the b to the bottom, we've got a b squared down there, and now we have negative 6 over b squared. Equally correct with the negative out front. Let's look at the third one. We've got 3c squared to the negative 4th all over c to the 5th. Now here we notice that everything in the numerator has a negative exponent, so it can be moved to the denominator if we make the exponent positive. So that gives us a 3c squared all to the 4th power in the bottom, and also the c to the 5th stays in the bottom. It doesn't move because it doesn't have a negative exponent, and this leaves us with 1 in the top, because technically that whole thing in parentheses was the same as 1 times that whole thing in parentheses. So we're left with a 1 in the top. Now we just have to deal with the bottom. If we distribute that exponent of 4 in the parentheses, we get 3 to the 4th, which is 81. C squared to the 4th is c to the 8th, and we still have the c to the 5th there. Combining the c's in the bottom requires we add the exponents, so that gives us c to the 13th. And our final answer is 1 over 81c to the 13th. All right, let's continue. We've got 5d to the negative 3rd to the negative 2nd. And here what I want to do is I want to distribute that exponent of negative 2 to both of the things in the parentheses. If we do that, it gives us 5 to the negative 2nd times, if we look at the d, we've got an exponent on top of an exponent, which means we multiply them. Negative 3 times negative 2 is positive 6. So in the end, we've got a positive exponent on that variable. So now the only thing that needs to move is the 5, because it's the only thing that's affected by a negative exponent. We keep the d to the 6th in the numerator, and bring that 5 into the denominator as 5 squared, which we know is 25. So we end up with d to the 6th all over 25. You could have started that problem by taking that negative 2 exponent and using it to move everything into the denominator, but then we'd have a negative exponent on the d in the denominator, which would mean it would have to go back up to the numerator. So there's a lot more moving things around if we don't distribute that negative 2. If you want, you can give it a try and make sure that you end up getting the same answer in the end. Now, our last problem is going to be 3z to the 6th over 6z cubed, all to the negative 2nd. Now, we could distribute that negative exponent to the top and the bottom. We could also use it to flip everything and make it positive. But before we do anything else, I think the best move is to simplify the fraction inside the parentheses. If we do that, 3/6 becomes 1/2. And then z to the 6th over z cubed becomes z cubed. We can write this a little bit more succinctly as z cubed over 2, all to the negative 2nd power. And now we can make that exponent positive by flipping the fraction inside. So we've got 2 over z cubed, all squared. And when we distribute that exponent in the top and the bottom, 2 squared is 4. Z cubed squared is z to the 6th. And so we have 4 over z to the 6th. If you had distributed that exponent in the very beginning, before simplifying things, you would end up with a lot more work on your hands.